All right, so we're looking at 10.8, solving inequalities. All right. So up to this point, we had we've been dealing with linear equations, and that's what we're looking at in this first set right here, this first example. And then, but what we're going to look at in this section will be linear inequalities. So there are a few differences between the two. All right, a few differences between the two. First one is that an inequality has an equal sign. I said inequality. An equation has an equal sign, and an inequality has your inequality symbol, one of our inequality symbols. All right, so because of that, when we solve this equation, we would only have one solution. That solution would be 1, x equal to 1. And once again, you would only have that one solution. When you solve an inequality, you're going to have infinitely many solutions. And that will give you a solution set. So notice, like I said, going back to your equation, you have x is equal to 1 as your solution. The only value that works for that is 1. You want to know, when is 2x plus 5 equal to 7? That's when x is equal to 1. But then when you look at this one, it says, when is 2x plus 5 greater than 7? Well, you have infinitely many values that you can plug in for x to make that a true statement. You can plug in 2. 2 times 2 is 4. 4 plus 5 will give you 9. So 9 is greater than 7. You can plug in 100. You can plug in 1 million. You can plug in anything that will make the left side greater than 7. So when you solve it, you'll come down here and have x is greater than 1. So any value greater than 1 will be a solution for that inequality. Also notice that this last statement down here, 1 is not a solution. So if we were to plug 1 in there, 1 is when it's equal to 7. We want to know what will make that side greater than 7. All right, and once again, that is a solution set. This is considered a solution set. Represents the set of all values that will make that a true statement. Okay, no problem. Thank you for letting me know. All right. So now when we go to solve these, we'll solve them the same way we solved our equations. And I'll show you in a second. Looking at this 2x plus 5 is greater than 7. Just want to make sure everybody got it. We're going to solve it the same way. There's one thing that we have to consider. We'll talk about that in a second. But solving this, you will solve it the same way. So if I want to solve 2x plus 5 is greater than 7, I'm going to subtract 5 from both sides, divide by 2, and that's where I get this x is greater than 1 from. So once again, it's the same process you would take if this greater than symbol was the equal sign. Subtract both sides by 5, divide by 2. So any questions before we go to the next thing? All right, scrolling up. So here are our 4 inequality symbols, the ones that we will be using. We have less than with the bar under it will be less than or equal to. Greater than with the bar under it is greater than or equal to. So scrolling up to make sure we know what that means when we solve. So if I solve and I have x is greater than 2, that means I want all values that are greater than 2. And we recognize that 2 is not a part of the solution set. But if it says x is greater than or equal to 2, my solution will be all values that are greater than or equal to 2. That means 2 is a part of the solution set. All right. Is everybody okay? So just setting this up, make sure we're okay with what's going on. All right, let's scroll up. Okay, so the next piece of what we will be doing with these is your interval notation. If we're using the less than or greater than symbol, then we're going to use parentheses. If you dealt with these before, we use open and closed circle. This is the same thing as an open circle. If it's less than or equal to, greater than or equal to, we use bracket. This is the same thing as your closed circle. All right. But if you have no recollection of open and closed circles, then don't even worry about that. Like I said, that's for those who remember how to use open and closed circles, use them the same way. So you use parentheses for open circle, bracket for closed circles. So parentheses mean you will exclude the value. In other words, you will not use that value. Bracket means you will use the value. And then for your infinity signs, you will always use parentheses. And that goes back to what we were saying. When I say not use or use, that goes back here. And I'm going to go back down in a second. Notice when we have parentheses, not parentheses, and greater than, we do not use that 2. But when we have greater than or equal to, we do use the 2. So that this parentheses and bracket will still reflect what happens in the other part of our answer. So that down in the red just shows us how we would use it. We have x is greater than 2. So you're talking about the values greater than 2. That's 2 to positive infinity. Notice we're using parentheses on the 2 and parentheses on your infinity sign. Once again, you will always use parentheses on your infinity sign. And because I have the greater than symbol means I will use parentheses on the 2. Then if I have the or equal to symbol, that means I use a bracket on the 2. But once again, still using parentheses on your infinity sign. All right. Questions? Any questions? All right. So we're also going to graph on the just generic number line using the fact, like right here, you see we have just 0 in the middle. Everything to the right of 0 is positive. Everything to the left of 0 is negative. And we're just going from there, just recognizing anything to the right of a number is always going to be greater than it. Anything to the left of it will always be less than it. So that will always be the case. So I'm looking at the values that are greater than 2. And that's what we did here. Put a parentheses over the 2. Remember, when I have just the greater than symbol, you will always use parentheses. So I put a parentheses over 2. And the values that are greater than 2 will be to the right of it. So we shade to the right. Then when it's greater than or equal to, put the bracket over 2. and then shade to the right. All right, any questions? So you have those three parts of your answer. You have your solution set, your interval notation, and your graph. And then WebAssign can ask for all three, or just one of them, or maybe two out of the three. So you should be able to do all, do them accordingly. All right. So here we have a chart just showing us generically what should happen in each scenario. Notice right here in the green it says let A and B represent just real numbers. So we're going to treat those as real numbers. Looking at the first four. And the first two reflects what we were doing with the number 2. So we're just doing it generically. We're talking about x is greater than a. Interval notation, that's going to be a comma infinity. And then for your graph, you're shading from a to positive infinity using parentheses. Same thing happens with greater than or equal to, except we're using bracket. Right. So then if you want to represent the solution set of the values that are less than a, we use parentheses over a, but we're shading to the left. That's what's going on in this third row. And then less than or equal to, we use a bracket, but we're still shading to the left. All right. Questions? Any questions? All right, next 4. So this will happen whenever we have a 3-part inequality. I think you guys are going to get that and make sure. Yes, yeah, you'll have a 3-part inequality, so that's fine. So whenever you have a 3-part inequality, notice x is in the middle. So that's what you solve for. So you want the values that are greater than a but less than b. So those are the values in the middle. So you shade in the middle, and we use parentheses over both. Now we have the or equal to. Once we see that, and that means we use a bracket. So we have the bracket over a, parentheses over b. And we're still shading in the middle, but we still keep those symbols of bracket and parentheses. Same thing happens here, just that this time we have parentheses over the a, bracket over b, and then in the last one you have bracket over both. All right, any questions? All right, let's scroll up. All right, so as I mentioned, there's one thing that we do have to consider when we're dealing with solving inequalities that we didn't have to consider when solving just equations. It says when solving inequalities, and you have to multiply or divide by a negative number, then you must change or flip the inequality symbol. And solving inequalities. Go ahead and write it out. Must have got lazy at the moment. All right, so when solving inequalities, you have to multiply. Yep, okay. All right. So quick example of that. Just doing this without anything. So if I have negative 3x is greater than 5, if I were to divide both sides by negative 3 to solve, oh, sorry about that. So dividing both sides by negative 3 to solve, this greater than symbol has to go to less than in order for it to stay true after I divide by negative 3, and that gives me the solution of x is less than negative 5/3. So the other parts of this answer, right here and right here. So if you're talking about all the values that are less than negative 5/3, you would be shading to the left. And because this less than and not the or equal to part is involved, you would be using parentheses. And then the same thing is reflected in your interval notation. We're going from negative 5/3 to negative infinity. So it's, and notice the order of the way it's written. The negative infinity, you always read it from left to right. So the negative infinity is written first, comma, negative 5/3, just in the same way as you see it, going from left to right in your number line. So it's negative infinity to negative 5/3. All right. Any problems? All right, so let's look at solving these. Remember, once again, you're solving these the same way you would your equations, regular equations. This was an equal sign, you will still be solving it the same way. So we recognize that we have 5x and 4x on different sides of the equation or different sides of the inequality. So we need to take all of our terms with x to one side, take all of our terms without x to the other. So we will be subtracting 4x from both sides. So the 4x cancels on the right, leaving us with x minus 6 is greater than 2. All right. And we're going to add 6 to both sides. And x is greater than 8. So that's going to cause us to go from 8 to positive infinity, shading to the right, using parentheses over our 8. right, questions before we do another one? All right, so the next one we have negative 5x minus 3 less than or equal to 12. First thing we'll do is add 3 to both sides. And then we'll be left with negative 5x less than or equal to 15. So don't forget, we're going to divide by negative 5. And if we do that, we have to change our sign. So because we divided both sides by negative 5, we need to change the sign. So it goes from less than to greater than. So x is greater than or equal to negative 3. So we're talking about values that are greater than 3. That means we're going to shade to the right. We're going to be using bracket because we have the or equal to. And then that goes from negative 3 to positive infinity. So that's why we have negative 3 comma infinity right here. Bracket over the negative 3. Parentheses will always be attached to your infinity sign. All right. Questions? Any questions? Scroll up. Good. All right. So next type of problem is 3-part inequality. And if you go back to the chart that we had, remember those are the last 4 where you had a number, then the x was in the middle, and it was looking like that. So what we want to do is solve this, but leave x in the middle. And so the way we would solve this, if we didn't have this part over here, what we would do is subtract 1 from both sides of the equation. So that's what we would do to all 3 parts, because we have 3 parts. We have 1, 2, 3 parts. So we'll subtract 1 from all 3 parts of the inequality. All right. So that negative 1 will cancel out the 1 in the middle. And that'll leave us with negative 4 on the left, because negative 3 and negative 1 comes together, give us negative 4, 2x in the middle, and then 7 minus 1, which is 6 on the right. All right. Then we can finish it off by dividing both sides by 2, or dividing each part by 2. Because remember, your goal is to get 2 by itself. And we'll finish it off with x being greater than or equal to negative 2, but less than 3. Then our 3 parts will look like this. I don't say the 3 parts, our 3-part inequality will look like this with our interval notation, shading the values in between 3 and negative 2, bracket over the negative 2, parentheses over 3, and then interval notation reflecting negative 2 comma 3, bracket over the 2, parentheses over the 3. Any questions? Any questions? All right. Everybody good? Everybody kind of go off of this page. All right. I think it's factor. Okay. So we're going to stop right here. That's it for chapter 10. So next class, we're looking into 11.1 and 11.2, which is graphing for us. See what we got going on here, 11.6. So yeah, 11.1, 11.2, and 11.6. So that's it out of chapter 11 as well. So anyway, we will, like I said, we'll pause right here. And next class, we'll get into chapter 11. And I'm going to check to make sure to see how we want to break up this homework as far as the test and everything is concerned. But before we leave, any questions on anything? Everybody good? Everybody straight? All right. So you guys have a great weekend. Be safe. And I'll see you on Monday. All right. Thank you. Thank you. Everybody take care.